thanks for listening. Today I want to tell you about how I built a multi-platform game engine using Kotlin. First of all, just a little bit about me. I was already introduced, but I'll just say most of it again. As you've heard, I really love reading and playing board games. I also enjoy singing and hiking. I currently work for Entelect, usually in Java, sometimes Angular too. And if you want to find me online, you can find me on GitHub, Mistborn94, and on Twitter, Babalela01. First of all, I need to clarify what I mean by multi-platform. Java already gave us the multi-platform promise of build once, run anywhere, with the caveat, run anywhere where the JVM runs. Kotlin Multiplatform is a little bit different. With Kotlin Multiplatform, we write a code once and then compile it to different targets. First, to JavaScript, so we can create a web playable version of our game, and then also to the JVM for the actual project. What game is this? The game I'm talking about is the game we built for the Entelect Challenge this year. The Entelect Challenge is an annual coding competition where contestants submit bots to play a retro or classic game, and this year our game was Worms. In our version of the game, which was a slight adaptation because we needed to make it playable and exciting for the bots to play, each player plays with 3 worms that move, dig, and shoot across the map and try to eliminate each other. So the game engine is really the core part of the game. This is the part we have to redo every year. When the worms run, shoot, dig across the map, this is the part that manages all the state, what the players are doing, where they are, what their health is, how many worms are left, enforce the worm interactions, when you shoot someone, what happens, when you dig a block, what happens, and enforces the rules, where you're allowed to move, what you're allowed to shoot. And this is really the core part that the challenge couldn't do without. This game engine, even though we call it a game engine, is a little bit different from a traditional game engine. In a traditional game engine, we have our players, we have our environment, we have physics and graphics and rules. But our game engine also has a little bit of overlap with the enterprise system. When we say enterprise system, we think more generally enterprise integrations, async and threading, logging, I/O, and web support. What we wanted was most of the things a traditional game engine gives us, but a little bit more. So we have players and environment and sort of physics, but nothing as big as a traditional game engine would give you. And we also have rules. But from the enterprise side, we have logging. We need to be able to track what's happening in this game engine, since we are giving away quite a lot of money. We needed I/O to read the bot commands, read the state files, output the state files for the bots to use. And we wanted web support. We wanted to build a web version of this engine so humans can play and see what our game is about. So, why Kotlin? Since you're at Kotlin everywhere, I assume you know Kotlin and love Kotlin, but I'm still gonna go through why we chose Kotlin. But before I go into that, I want to go on a bit of a tangent about types of programming languages. When we think programming languages, the 2 broad categories we think of are usually object-oriented languages and functional languages. And Kotlin fits into both of these a bit, as I'll show you now. When we think object-oriented, we think classes, we think polymorphism, we think inheritance, we think encapsulating things. When we think functional, we think higher order functions, pure functions, first class functions, immutability. Kotlin is both of these. Object-oriented Kotlin, we have classes with methods and properties like in most other object-oriented languages. We have objects, we have inheritance, we have delegation, since most of us learn quickly that inheritance isn't always as great as it sounds. And we have extension functions to make non-object-oriented code look a little bit nicer. Then on the functional side, Kotlin has top-level functions. You can do stuff without it being in a class. You can have first-class functions, so you can pass your functions around and have lambdas. And lambdas just work, and they're a first-class language feature. And we have a strong focus on immutability and doing the sensible thing by default. In addition to the overlap between functional and object-oriented, one of the big advantages of Kotlin is null safety at compile time, which makes our code safer. We have type inference, which reduces a lot of boilerplate code. And we have conciseness. This is just one example of data classes that was already covered in an earlier session, but there's many examples of Kotlin making our code a lot more concise. Besides the technical reasons, there's also good, sensible reasons to use Kotlin. It's developed by JetBrains, since many of us use their IDEs. We know they know what they're doing. It has full interop with Java, so if you're working on an existing Java system or Java app, you can run Kotlin alongside it without migrating everything. It has full support for Spring. This is a big thing for me because I work with Spring a lot, but also Spring is one of the biggest web frameworks and even bigger than web for the JVM. And lastly, it's the recommended language for Android development. So there we've got another giant behind this language. But choosing a language is never as simple as it's a good choice. We all know that. So why did we really pick Kotlin? First of all, for fun. Coding Kotlin just makes me happy. And with the Entelect Challenge project, I got to share that with more people. For learning, I really wanted to use Kotlin on a scale that's a little bit bigger than my standard hackathon or Advent of Code or coding challenge. And lastly, because code once. When I was introducing Kotlin, my co-developer in the game engine was like, you know, I would really like to build or transpile this project to JavaScript. I was like, so there's this thing called Kotlin Multiplatform. So how do you do Kotlin Multiplatform? First, there's the old way. And this was before I knew about the right way and before I knew about how to Google to find the right way. So what you do is you create a multi-project build, apply different plugins to the different sub-projects, and override the source sets to share one common folder. There are some challenges with this approach. First of all, IDE support wasn't great. My IDE didn't necessarily realize that this shared module is supposed to be pure Kotlin common code. So what that meant was I had to keep loading and unloading my different modules to make sure the common code I'm working on is really common. The second part was I had to apply different plugins to different subprojects, and that led to quite a convoluted build script. And because of those two and some other reasons, it really just felt hacky. The new way. So the new way to do Kotlin Multiplatform is you can apply a single plugin, the Kotlin Multiplatform plugin. This plugin is still experimental. It was introduced in Kotlin 1.2, kind of reworked in 1.3, and I hope it will be stable in 1.4. You define multiple targets for your different languages, and you can have a dependency mechanism between those different targets and your common modules. And if you need to plug in platform-specific code, the language provides the expect and actual mechanism, so it's easy to plug in. So basically what we have, this is a little diagram Kotlin Lang website uses to explain the structure. You have your targets, in this case JVM and JavaScript. Each of those have main and test classes with source sets. And then there's also a common module that everything is dependent on. This is pure Kotlin code that's shared between everything. I want to show you a little demo. How do I close this presentation mode? Wait, there it is. Sorry, not my laptop. No, it's not. I have to check out master to build it. Okay, so first of all, I just want to show you how you get your build file set up to build this multi-platform Kotlin project. This is just a simple example using Java and JavaScript as my targets. So first of all, come on, why are you not working? Oh no. Okay, my templates don't want to work. Back to master it is. And I'll just show you. So the first step you have to do is you have to apply the Kotlin Multiplatform plugin. So it's very easy. You'll notice I used the Kotlin DSL for my build script. I'll get to the reasons for that a little bit later. You just apply the Kotlin plugin. This little Kotlin function is a shorthand provided by Gradle to apply any Kotlin plugin. The name multi-platform with the version. Next up, we define our targets. So in this case, I want to define a JVM target. Here, I'm happy just using the default name. And I also want to define a JS target, but I want to give it the name with. After we've defined our targets, we need to define our source sets and set up our dependencies. The first one is common main. This is the production code that's shared between all the different modules, all the different source sets. Any dependencies you list here have to be Kotlin multi-platform dependencies. In this case, we want to keep it simple. We're just using the standard lib, but there's many different ones available. From Kotlin specifically, there's logging, there's serialization, and there's a bunch. If there's libraries you need to use that don't have multi-platform versions available, you might have to wrap them yourself. I'll get to that in a bit. After common main, we define our test module for common. So any test you write in the common test module will be compiled for all your platforms, which is pretty cool. Here we once again just add two simple dependencies. We have the JVM main, and here in your actual target declarations, you have to now add a platform-specific versions of those common libraries you're importing. So here we have the standard lib for JDK. And in the JavaScript version, we have the standard lib for JavaScript. That's the most important part of our build script. Now, a few other things you might need to do. Change the module kind. If I think you're using your Kotlin JS project in any context outside a very simple web project, you'll have to change the bundle type to not use the default module. So I chose UMD, that's Unified Module Definition, means you can use it in your browser or Node or really anywhere. I also wrote a little script just to copy all my JavaScript files to a single directory so I can easily just run the HTML file in my browser and see what happens. This is just copying all my package.json, all my node modules, package.json, JavaScript files into the package directory. And then I created a task to execute my Java classes just because it's easier than figuring out what's my class path, what's my dependencies, what do I need without building a fat jar. And that's my build script. So once you have this build script, you can go look at the code. So first, no, not there, cancel. First we have common main. This app is a very simple logging app. So first we declare an interface for our logger. This logger can do only one thing. We can log a message to, in Java's case, the console, in JavaScript's case, to the console and to your web document. Then we create a logger factory. This is where the actual multi-platform aspect comes in. As you'll notice, this is an object, but it isn't actually implemented. Because we use this expect declaration, it's implemented in every of the targets. In any other code, we can still reference this. So in our main code, we can just reference that logger factory. And when it's compiled, Kotlin will pick the correct one based on your target. In this module, we can't write any platform-specific code. So if we try that, and IntelliJ doesn't want to index right now, but this won't actually compile. Now, to our JVM module. In our JVM module, we have a single thing. We just implement the logger factory and then implement the logger. So all the logger factory does, it's going to return our Java logger. This here, we can now use any Java-specific APIs we wanted to, unlike in the common module. And we log our message. In the JavaScript version, similar thing. We implement the logger factory using the actual keyword to indicate that this is now the actual implementation. It's very important your signatures have to be exactly the same. That if you don't, you will get compile errors with expect and actual if you don't provide implementation. Then we have our JS logger. Here we use JavaScript specific APIs and log this message. Now, that demo. So here you can see this is what a little demo does. If I refresh it, you can see it updates the time. And it's also going to log it to the console. So this is a little JavaScript demo. When I refresh it, you'll notice the time updates because it logs the current time. The Java demo. So I first need to build it with Gradle. Oh, come on. I fixed all of this before. Now we're going to build it, and you'll see down here it says build successful because I've built all of this before, and now we want to execute it. You can see down here it logs my Java, and this is clearly the Java logger. It has the little Java keyword. So that's the very simple demo. So a quick recap of what's happening here. First, we add the Kotlin Multiplatform plugin with the newest version. You configure your targets. And your targets, I'm just using Java and JavaScript as the example because those are the ones I've worked with. But you can also have native or Android and native for Linux, Mac, or Windows as your targets. And the interesting fact is that even the standard Kotlin native uses the multi-platform approach because all the native platforms are kind of different. Next up, we have to add our dependencies. Think very careful about dependencies you want to include here, especially if you want to integrate with existing JavaScript code. JavaScript dependencies are a bit of a pain, so think carefully about dependencies you need. You will have to include them in your final result too, somehow. Next up, write your code, the fun part. You put them in whichever sources you need, common and shared between everything, and then your modules or your platform-specific modules. Now, this didn't go as easy as we hoped everything would. There were some challenges. The first thing was it's very new. As I've said, it is experimental, and this approach was revamped between Kotlin 1.2 and 1.3. That means while the Kotlin Lang documentation is okay, sometimes you need other documentation or other examples, and third-party examples are really hard to find. And sure, I can write code to solve the standard problems, but when it comes to stuff like changing my build script to build a fat jar or check coverage, or how to link this common code up to the Java APIs I have to implement, it becomes harder. The next challenge was Gradle and Groovy. First of all, IDE support for Gradle and Groovy in IntelliJ really wasn't great, especially if you don't know the plugin, you don't know your options, and you're kind of unfamiliar with both Gradle and Kotlin Multiplatform. And I don't know, Groovy and I just don't get along. Next up, we have JavaScript and TypeScript interop. Because we wanted to pull our app into the website, and our existing website that was built using TypeScript and Angular, this really was our biggest headache. So, first of all, overloads. While Kotlin has the concept of overloads, JavaScript does not. So what happened was any function you define for Kotlin JS, the compiler goes and renames it for you to make sure there's no clashes or anything. The next headache we had was type definitions. Kotlin JS does not generate type definitions for you, yet. It's on their issue tracker. We're hoping it comes with Kotlin 1.4. But when you need to integrate an existing TypeScript app, that's a bit annoying. Next up, module types. I've already mentioned the module type, but the first time we did this, we just expected for it to work out of the box. And then you get things like Kotlin is undefined. We also had some issues with dependencies. Any dependency for Kotlin JS you pull into your Gradle build file to get this thing compiling, you also have to pull in at runtime, which means we had to either, if it was on npm, install it through our package.json, or install it using some other mechanism. Like I've said, there are some quirks with Kotlin JS interop. Packages I've already mentioned. Packages I haven't mentioned. When you create packages in your Kotlin, because we don't have the concept of packages in JavaScript, it creates an object that kind of nets all your packages in. So if your package is ZACO something, your JavaScript export will be an object with ZACO and stuff in. How we solved it really was just by creating a few clauses in our root package to just orchestrate things, create things, give us references to the things we need. Number types. I'm sure if you worked with TypeScript, you've encountered a similar issue before, but sometimes when we called our code from JavaScript, we told Kotlin, hey, this will be an int or a long, but JavaScript just thinks it's a number. Similar issues I've encountered with working with TypeScript and interacting with external APIs and telling TypeScript its clauses. So this took us a while to figure out what's actually happening, but be careful if you're interopting with non-Kotlin code. And lastly, overloads. I've already mentioned that the compiler renames functions to prevent name clashes because JavaScript does not have overloads. Luckily, you can control this using the JS name annotation. So besides all of this, would I still use Kotlin JS again? And kind of what does the Kotlin JS compiler do for us? So first of all, you get to use the Kotlin standard library. You get to code Kotlin instead of JavaScript. You get fairly readable JavaScript out of this. It's not, you can see it wasn't written by a human, but you can still see what it's doing. And you can target either client or server-side JavaScript, or both. Now, we all know JavaScript transpiling is a popular hobby, so Kotlin, within good reason, so Kotlin Multiplatform might not be the solution for you. There's many other tools doing the same job. There's TypeScript and CoffeeScript, which both just try to be better JavaScripts. We've got Google Web Toolkit and Java to Clojure, which both try to compile Java to JavaScript. We have Babel, which transpiles JavaScript to JavaScript, new JavaScript to old JavaScript. We've got the same kind of thing for Python, Ruby, .NET, and probably many more. So, the result, Java. Here you can see a little screenshot. This is a screenshot from the Java console when two bots are playing against each other. You can see those little numbers represent worms, and there's walls and walking spaces and stuff. And then the version. So this is the little human playable version. It's a tiny bit cut off, but this is the end result we got. So we can play with these little worms. And this was all built of the same game engine that we used to power our competition. There's another screenshot of a bit of an older version. So, where's Kotlin Multiplatform going? I don't know, but I think it's pretty exciting and it has a huge amount of options. So, if you want to find my source code online, you can find a simple example on my profile, or you can go look at this game engine we implemented using Kotlin Multiplatform. Thank you, everyone. Is there any questions?
Okay, so I just want to understand something. So it's a multi-platform, right? And when you started, you said it's called once. But I realized on your mains, so you have a JVM main, you've got a JS
Yes.
main, but then you have local classes on each of them.
Yeah, so you don't actually need that. I have it just to show that you can actually plug in multi-platform code, but you don't actually need it. Any code you write in common gets compiled to both. So if you don't need to write platform-specific code because the Kotlin standard lib is sufficient, or your other multi-platform libraries are sufficient, then you don't need to write any platform-specific code. But sometimes you just can't. Sometimes stuff needs to work differently on different platforms, and that's where the expect an actual plugin works.
So in that case, say for instance you need a Android specific library. Then how do you handle that in the dependencies?
Yeah. So what we ended up doing when we had some Java specific things was we used this expect actual mechanism to kind of create a wrapper that just encapsulates the logic we need, and then import the Android specific version or the Java specific version in that module. So So in my build.gradle, right here, you'll see there's dependencies for JVM and dependencies for Java. You can, for web, you can pull anything in here you want to.
Okay.
And then if you want to somehow access that from the common module, that's when you'll have to use this expect and actuals to get access to that. Thank you, everyone.